So we are going to be plotting graph of t square against h. So if you have not seen the experiment, you can check the previous video to see the experiment, and this is the readings for the experiment. So if you see plot t square against h, it simply means plot t square on the vertical and plot h on the horizontal. Plot h on the horizontal. So this is a graph. Okay, so here is the vertical, and this down one, ground level, is called the horizontal. So it means that we have our t square on this side, and then we have our h on this side. So the first thing you would do is to plot your vertical lines. So we're going to be plotting the vertical lines like this. You have to use pencil, so I'm using biro because of this video so that it can be visible. Okay, so I'm using biro because I want it to be visible. Okay, so you put an arrowhead on this side, you put an arrowhead on this side, then you label appropriately. So we have t square on this side in second squared, and then we have h in centimeter. Okay, so now the next thing we will do is to check our readings. So if you check at t square, the highest value we have is approximately 9. The lowest value is what? 4. Okay, this is for the horizontal. So you come back to your graph and check. Look at it. You see this big, please bring it down a little bit. I want you to see this box very well. Bring it down a little bit. Bring it down, bring it down, bring it down. So you see this box, this big box, this is 2 centimeter. Each of these big box you are seeing is 2 centimeter. All right, now we have our highest to be 9. You just have to play around numbers until you have something reasonable. That's why it's called reasonable scale. Okay, something reasonable. It's not fixed. You have to use a reasonable scale for your reading. So we have the highest to be 9. So let's run with 1 first. So if you do 1, 2, 3, 4, 5, 6, 7, 8, 9, I think this is cool. So we're going to be using 2 centimeter for what? 1 unit. So we are going to do it like this now. 1, 2, 3, 3, 4, 5, 6, 7, 8, 9. So please, you don't have to cover, your numbers mustn't cover everything on the graph. Okay, the idea is that your graph should cover like 2/3 of your graph. Okay, whatever you are plotting should be 2/3 of your total graph. All right, so this is what we have this unit. So what it means is that on the vertical we have 2 centimeter. 2 centimeter represents 1 unit. Okay, remember the highest is 9, approximately 9, and we have 10 altogether. 2 centimeter. All right, now the next one is h. So we have 30, 60, 90. So let's check it out. Let's do 10. The highest is 150, the smallest is 30. So let's do 10. So let's do 10 for 2 centimeter, 10 units for 2 centimeter, and see how it goes. The highest is 150, remember. 10, 20, 30, bring it down. 40, 50, 60, 70, 80, 90, 100, and the highest is 150. So we can't use that scale. Let's try 20 for 2 centimeter. So I think this will go. So remember to put your 0, 0 here, even if they did not ask you to start from 0, 0. So you are going to put it 0, 0. Okay, so we are doing 20 for 2 centimeters. So we have 20, 40, 60, 80, 100, 120, 140, and 160. 60. Thank you. So this is what we have. Now before we plot, I want you to understand so that you will know how to plot graph well. So now look at this. We have 9.2 approximately. So we are going to be plotting one decimal for this. So it means for this we approximate to 9.2. Here we have 8.2. Here we have 7.3. Here we have 5.9. Here we have 4.6. all right. So now if you look at this, I want you to understand how to plot graph, right? So if you look at this graph, from here to here is 1. So it means half of it is going to be what? 0.5. Correspond. Okay, half of it is going to be what? 0.5. all right. So now what does that mean? We have 10 smaller cells inside this big box. There are 10 smaller cells. Okay, so it means half of it is going to be 0.5. What does that mean? And the half is going to be 5 lines. It means each line is going to be 0.1. So we have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. I hope you are not going to say 0.10. So the next one is going to be what? 1.0. all right, I hope you understand. So now this is going to be from here to here is going to be what? 20. Let's understand the horizontal. If 2 centimeters is 20, it means half of it is going to be 10. What does that mean? It means 5 lines is going to be what? 10. If 10 lines is what? 20. 5 lines is going to be what? 10. Okay, so it means we have 10 in the middle here, 20, we have 30, and then 40, like that. Now that we have that understanding, let's plot our graph. So we have for t-square we have 9.2 approximately. In one decimal place we have 9.2. so we have, this is 9. So if this is 9, we have 9.1, 9.2. so we have 9.2 somewhere against what? 30. 9.2 against 30. Where is 30? 30 is going to be in the middle here. 30 is going to be what? In the middle here against 9.2. 30 is 1, 2, 3, 4, 5. So it's going to be here. So you put a plus here and then you circle. So what is the next one? The next one is what? 8.2. Okay, let's find 8.2. 8.2 is going to be somewhere here. 1, 2, 8.2 against what? 60. So let's go and find 60. So this is 60. This is what? 60. So 8.2 is going to be 0.1, 0.2, and this is where 60 is, right? So we have this. It is okay for you to confirm from here, right? We have 20, we have 40, and then we have 60. Okay, you mustn't come down here to confirm. So the next one is what? 7.3. So this is 7. Okay, 7.3 against what? 90. Where is 90? This is 90. 90 is in the middle here. Let's take it up, take it up, take it up. This is it. Against what? 7.3. This is 7, right? Yes. So we have, let me count the lines first. 1, 2, 3, 4, 5, right? Against 3, right? Yes. 1, 2, 3. So we have it here. Then you cycle. Then the next one is what? 5.9. So this is our 5, right? 5.9 is going to be somewhere here against what? 120. Where is 120? 120 is on this line. So we have 120 here, right? 120. This is 120. Then 5.9. So 5 is here, right? This is 5. 5.9 will be what? Against 120. It's going to be here. 9. 1 less than 6 now. So we have the next one is what? 4.6. So this is 4. So 0.6 is going to be somewhere here against what? 150. Let's find 150 first. 150 is in the middle here against 4 point something. So let's count. 1, 2, 3, 4, 5 is somewhere here. 4.6, right? So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, right? Let me be sure. 1, 2, 3, 4, 5. Yeah. So this is it, right? Now we are done with plotting our graphs. We have find our point, the next thing is to pick the line of best fit. So to find the line of best fit, okay, all the points must not necessarily be on the line. At least 2 points is fine. At least 2 points is fine. So we are going to be picking, usually it is advisable for you to use a transparent ruler, a long transparent ruler, instead of this opaque ruler. Okay, so but I'll manage this one, but it won't give me what I want because I won't be able to see the line. So I will just pick these 2 points, but usually the 3 points should not be on one side. If 3 points are going to be out of the line, 2 should be on this side and 1 should be on the other side. The 3 points should not be on one side of the line. Okay, so let's see, let me go for these points and this point. Yeah, these points, I think I have it here. This is my line of best fit, this point and this point. So, and then you draw I'll shift my ruler in case they ask me for intercepts. I won't have to come back to draw the line. So this is it, right? I'll still extend my ruler backward. I want something perfect, so this is it. So yeah, this is my line. Okay, now this is it. So in the next video, I want to make this video as short as possible. I'll be talking about the sloping.